station on 2.
I'm Don Pettit. I'm on the International Space Station. And I'm going to show you some interesting observations about water sheets. Here in a weightless environment on the International Space Station, you can make films of pure water. It's like trying to stick a loop in a bottle of water and pulling out a film. You just can't do that on Earth. You have to add soap. And I'm going to use a number of different geometries, a number of different kinds of loops, and a number of different experiments with these water films. So you could look, for example, at diffusion in water, say of food coloring or any other substance you want in water. You could look at the diffusion in a two-dimensional sheet.
Because these water sheets are so thin, convection perpendicular to the sheet will not be a factor, and you can just look at fluid motion within the plane of the water sheet. So here I put a drop of blue food coloring and a drop of red food coloring and a drop of green food coloring, and then you give it a little puff of air. And the viscous forces in these thin sheets are small compared to the fluid motion, so they will continue to spin like this for 5 or 10 minutes until the viscous forces will eventually have them slow down. And the food coloring will get stretched out and leave streak lines. And if you do too much convection in here, then you end up with just this black sheet. Here's another water sheet example, and this one is thin. This one's about 200 microns thick, and again, I'm putting red food coloring on. And when you put a drop of red food coloring on, notice those little vortices, those little swirls that kind of look like mushroom caps. Really what you're seeing is a cross-section through a vortex ring. And here I'm going to put a little puff of air. I'm going to generate another two-dimensional equivalent of a vortex ring. And again, it looks more like a mushroom cap, but this is what a vortex ring would look like if you were able to take a slice through it.
And now I've got a sheet that's actually it's a little thinner than the wire now that's suspending it. You can see if these shades are slightly convex, that means they're thicker in the middle. Then at the edges, it makes a convex lens, and it's a positive lens. If they're slightly concaved, then, which means it's thinner in the middle, then at the edges, it makes a negative lens, so things look smaller. And this one is actually pretty much parallel. It doesn't seem to make my face there. Actually, I think it makes me look better, don't you? Look at that.